In most languages, the simplest form of a complex data type is an array. Now, in some languages like C and C++, there's not much complexity to an array. In other languages like Python, they have a list which is like an array, but not like an array. So what we're going to do is we're going to focus on a standard array using Java. That is something that is both statically typed, i.e. it can only be one type of data, and something that is statically sized. That is, once we create the size, we cannot adjust the size of our array, either up or down. So let's take a look in Java how we're going to do an array. Inside of a Java app, we already have an array, and that's that string args that's part of the main. So you can pass in an array of strings and work with that as a series of arguments to start your application. Now, that is not done very often anymore, so we're going to focus on something else, and we're going to see how we're going to create some different arrays. So what I'm going to do is I'm going to create an array of integers. Notice that I had to use new. So in Java's case, the array is actually an object, and that's kind of how it's being treated. It's a pointer to a reference, and then we're going to have some properties and methods that are available to us in order to make using an array easier. Let's say I want to get the array size. Well, I could come in here and say size equals my array dot length. And length, you're going to notice, is a property that's publicly accessible that we can read. It's a read-only property, but it's a property we can read, and we can now get the size of our array. So if we come in here and say system.out when I run this, you're going to notice it's going to come up and say, hey, the size of the array is 10. Now notice I don't have any elements inside that array, but it automatically knows that I have a size property. That's because it's statically sized. Once we create it, that's the size it is. Now the nice thing about an array is I can create for any data type I want. Sure, I can use doubles and ints and things like that. I can use strings, which gives me an object that's built in, or I can use my own class definitions to create an array of objects that are user-defined. So I could create a user-defined array of students, or of products, or of orders, or anything else that I need. The key is to know when to use the array. And the array is going to be great for if I have something that's not going to be changing much in size. For example, maybe I'm creating an array of student grades. The number of students is not going to change for my class, and therefore the number of grades I need to enter in is not going to change as my application is running. Sure, it might change from semester to semester, but while the application is running as a minimum, in often cases, sometimes throughout the whole semester, there's not any changes. And so once I start my application, I can set it up and I have it running. So it's all about knowing when to use this. My array, because it's statically typed, means that I'm not going to have different types of objects inside of it. Now, if I have a generic object, I can use the polymorphic nature of Java in order to maybe assign some different Java objects, but that's a little complicated. We generally want to avoid that. Instead, we want to focus on having, hey, here's 10 students, or here's 50 grades, or here's 2,000 products. And Java arrays can be very large if we need to. Now, the second thing about the array, which is kind of unique, and it's not unique to Java, but it is unique to data types, is the fact that all of my elements are sequentially found in memory. That means that I have to have a space to put my 10 references to my data objects, or if they're primitives, I have to have a big enough space for my 10 primitives, or 100 or 1,000 or however many I have. Now, in older computer systems, when we only had maybe a megabyte of data, or maybe even a lot less, that could sometimes be a challenge. However, in the modern computer, where we're talking about having gigabytes of data, this is not a huge issue anymore. But what does happen is, because it's sequential, we can access that data very quickly. So a lot of times people look at it in something like a for loop. You say I is less than myArray dot length and notice that we access it by an index, and that's what we put inside our square brackets. Because of how it's stored internally and because it's sequential in nature, it means finding that element at whatever that index is very, very fast. And so that's a very important thing for us when we're looking for speed. This is something that adds up. So when you look at a statically sized array, like we find in Java or C++ or something like that, and we compare it to a dynamically sized data type. In Java, we have, for example, a vector. The vector is very easy to use, but we will notice a speed degradation when we're starting to move through it. So it's important to keep that in mind as we're developing our applications. Do we really need the ability for us to change the size of our array? If the answer is no, then we're going to leave it be. Now let's look just real quickly at a couple of other things we might find. I'm going to have over here int array2 equals myArray dot, and notice I have some other options. So for example, I can clone my array. This is real important, for example, because if I pass an array into a method, that array is a shallow copy, meaning that when it goes in, it's just a reference pointer, and any changes that occur inside of my new method happens to my original array because it is the original array. But I can do a clone to make a duplicate copy. Now I can change one without the other. You'll also notice that you have a toString method, and sometimes people get a little bit confused about how would I have a toString method for an array? Well, remember that in this case, an array is actually an object. And so because it's being treated as an object, it has that toString method. So we'd have to come to system as such. And if I go and run this now, you notice that what I get out is not something that's really beneficial to me. You notice, hey, what is this? It's I at, okay? So what this is doing is it's simply saying, hey, the I, probably short for integer in this case, and then it's at and a memory reference. So it's kind of that pseudo object. It is, but it isn't. This is not giving us anything beneficial. Notice that we don't print out the whole contents of the array like we would inside of a for loop. So if we want to find a way to print out the contents, like you might think of a Python list where it has a whole list you see in square brackets and stuff, we're going to have to develop something like that on our own. Luckily, this is an easy thing for us to do. It's just we have to keep this in the back of our mind whenever we're working with the arrays. So this is a real simple, easy to use type of data structure inside of Java. It's something we do see a lot of because of its usefulness and its speed and its memory management. It winds up being relatively efficient compared to some other data types. But it's also very simple, and it doesn't give us some additional methods and features that we might want to see other places. So understanding when to use an array versus when to use another type of data structure is very important inside of Java. And so we've just given you a start of this process. Stay tuned so you can look at how Java implements other types of data structures.